right here.
Hello, everyone. We'll get settled into our seats. If you're in the back and want to move on forward, please feel free. I don't bite. I don't think Amy does. We'll find out together. Good afternoon, everyone, and welcome to today's Science Cafe. I'm Dana Fulton, meteorologist, anchor, and producer at WKOW. Our station is proud to be the media sponsor for these events. I really love that the work that Clean Lakes Alliance does, so it's definitely worth it for me to stay up well past my bedtime to come hang out with you guys and partner with them for these events. We want to welcome everyone to the East Side Club today. Beautiful look out over the lakes there, just to your right, what we're going to be talking about. I hope everyone has been able to enjoy the cooler fall weather this week. Flannels out, nice jackets. This is my kind of temperature trend. Today's topic is one that comes up a lot when we're discussing the water quality of our lakes, and that's agriculture. Titled Agricultural Conservation Practices 101. Today's talk will be a look at some of our best management practices being implemented on farms throughout the county, such as cover crops and no-till practices. We're going to be reviewing the benefits of these practices and how they improve water quality and reduce agricultural runoff to our water bodies. Now, we will have time for a Q&A session at the end. I do ask that you try to hold your questions until then, so we all have that opportunity. We're going to get to as many as possible. We've had some really exciting conversations the last few rounds. If we don't get to everyone's questions, there will be an opportunity to email in your questions later, and we'll certainly make sure that they do get answered. Before we get going, I do want to give a quick thank you to our Clean Lakes 101 sponsors. Presenting sponsor, National Guardian Life Insurance Company. Hosting sponsor, the East Side Club. Supporting sponsor, Johnson Financial Group, Alliant Energy, and Perkins Coie. Production sponsors, the UW Nelson Institute for Environmental Studies and the UW Extension, and our media partner, WKOW. Again, very proud. It's not just myself, I can speak for the whole team. We're doing some pretty exciting stuff this week for Lake Week at the station. So if you have the opportunity to tune in at 6, you're going to see some cool stories coming through from the team. A few more quick updates, guys. On Thursday, October 16th, so 2 days away, if you don't keep track of the calendar, it's Imagine a Day Without Water. That's a day that invites us to reflect on how our health, our environment, and our economies are all connected and dependent on safe water. This week, WKOW, again, partnering and celebrating Imagine a Day Without Water. We've partnered with Clean Lakes Alliance throughout the week. We did have a really neat story just run last night with Lucas Kim talking about some of the work being done with cover crops. So it really ties into today's speech. Each day, we're going to be delivering daily lake-themed segments as part of our regular news broadcast that happens at 6, and then we'll recap them in the morning. If you haven't already, consider donating to Clean Lakes Alliance for their Imagine a Day Without Water fundraising campaign. Donations will fund their Seed the Need program, which provides support for projects happening throughout the watershed that benefit all of our lakes. Today's talk, let's get back to that. We're going to talk about agricultural practices in our watershed with Amy Piaget. Piaget? Yep. Yes, Amy Piaget. Since 2015, Amy Piaget has served as the County Conservationist for Dane County, overseeing some really cool projects, the Land Conservation Division within the Land and Water Resources Department. She has over 20 years of experience working at the intersection of non-point source pollution, state and county level. Amy currently serves as the treasurer of the Wisconsin Land and Water Conservation Association and the vice chair of the Wisconsin Standards Oversight Council. Here to share more. Here to share more, we want to use the stick mic. I'm fine yelling. I just don't want to make Amy. Thank you. All right. I only have one more sentence, guys. Here to share more with you about what farms are doing to improve soil health and reduce agricultural runoff. Please welcome me and join me in welcoming Amy.
Great. Well, good afternoon, everybody. My name is Amy Piaget. As she said, I have been the county conservationist for Dane County. Is that better? Can you hear me? Oh, my. Like, eat it.
That's it. We'll get new batteries in the other one.
Okay. Be really close. So I'm the county conservationist for Dane County. I cover our land conservation division, and we work with farmers across the county and private landowners on conservation practices. So we primarily do work with private landowners and assist them with conservation decisions. So today, what do you need the other mic? No. So today I'm going to kind of give an overview of some conservation practices that we typically work with in the county. So one of the questions we might get is, what is a conservation practice? These are typically choices that a landowner or an operator makes to manage their land. And they're used to protect the resource as well as manage farm economics. So it's a combination of making a choice to protect the land in a sustainable way, but also improve your economics as a farm or generating income. As a resource professional, for us, it's a tool to help conserve or improve our natural resources like our water quality, build soil health, and improve our climate resiliency. So a conservation practice can do a lot of different things. They can have a lot of different goals and focuses, and usually you're using them in what we consider a system. So one practice alone isn't going to help you. You need a system of practices. So with that, there are two different types of practices. We have what we call our structural practices, and these are also sometimes called hard practices. They're the types of things that we need usually an engineer to help us with, to design, do surveys, have construction workers out to install. Examples of this might be a manure storage facility, system, could also be grass waterways, or even filter strips or buffer strips, which we'll talk more about those. They have a longer life expectancy, so they usually have a designed expectancy. So they will be designed by an engineer to last 10 years, as long as they're operated and maintained throughout those 10 years. So they do require ongoing maintenance. The other type of practice that we have are what we call management practices. They have short lifespans, and they're usually implemented annually, but you can repeat them each year. Examples like this, and we will get more into it, will be cover crops or nutrient management or different tillage practices. And we'll go through what some of those mean. But they sometimes require specialized equipment. So if you're a farm that doesn't have that equipment, you may not be able to use all of these practices. So today we're going to focus mostly on the management practices, because those are the ones that affect most land, because they're going to impact cropland. But we'll also focus a couple slides on some structural practices, because again, those are done in the cropland and not on the production sites. So the first practice I want to talk about is nutrient management. And a simple way of putting that is nutrient management is a plan that the farmer develops with an agronomist or a resource professional, and it addresses what we call the 4 R's: the right rate, the right source, the right time, and the right place for nutrients to be put on the landscape to grow crops. So it's a plan that addresses all of those different components to grow crops for crop production. The benefits really here are that you're starting to budget. A farm can budget then the resources they, which seed do they need, which crops are they going to grow, what kind of nutrients are they going to use, how much of that nutrient. It helps them reduce input costs for developing the cropland and the nutrient management. It also helps improve kind of the physical, chemical, and biological aspects of the soil because you're not over applying nutrients or another one would be protecting water quality because you're not applying manure maybe at a time or phosphorus at a time when you shouldn't be, like during a rain event or next to a street. So a nutrient management plan consists of the plan itself, all the crops that the farm is going to grow, as well as the nutrients that they're going to be putting in. And it has maps that help identify where all this is and what the right timing is. I kind of pulled out some data just to kind of show where we're at least in the Yahara watershed. So if you see the map, hopefully that's showing up. Everything in bright green is where we have a nutrient management plan in the Yahara watershed. So a lot of times we get questioned, well, how much nutrient management do we have out there? We need more nutrient management. When we look at this map, we actually are at almost 50% of the agricultural land covered by a nutrient management plan that is tracked by our department. So a lot of farms may have a nutrient management plan, but they may not be sending it into our department. So this is what's just tracked. If you look at the table, it might be a little hard to see, but you can see it's broken down by various watersheds. The larger watersheds have more acres, so they hopefully have more nutrient management. So you can kind of see here. Can't see it. It's not even fun. Let's see. If we look at the Wanakee Marsh 6 Mile, we have 11,000 acres covered under nutrient management, and there's 15,000 acres in the total watershed. So we're at over 70% coverage in that sub watershed. So we have a lot of farms out there that are implementing nutrient management and following these plans to install and also treat their nutrients in a sound way. You can also kind of tell in the southern part of the watershed, we don't have as much nutrient management. So that's an area where we are working more focused on to get more nutrient management coverage or to get the actual plans from the farmers so we can document it. So another practice, and this would be incorporated into a nutrient management plan, is crop rotation. You'll probably drive around the countryside and one year see corn. Next year, you might see soybeans. Year after that, you might see wheat. What we're doing is we're rotating those crops on the same piece of land in a recurring sequence. So they have what we call a crop rotation, might be corn, corn, beans, corn, corn, beans, corn, corn, beans. They might put alfalfa in that mix. They might put winter wheat in that mix. And it's a rotation that they go through that helps reduce soil because you're not just planting the same crop year in and year out. That also helps break weeds and insect and disease cycles. So you're again kind of building that biodiversity a little bit more soil. And then you can also add legumes to the mix, which if you know anything about peas or beans, things like that, they add nitrogen to the soil, which then helps future crops grow as well and reduces your nitrogen input in the future. So crop rotation is kind of a small practice in the sense of all the practices that we do. It's a pretty small one, but I would say almost all farmers practice some type of crop rotation. So the next one is what we call nodal or strip. And this is when you're trying to plant your crops without disturbing the soil, or as minimal soil disturbance as you can get. The typical way that was done in the past is you go and plow your field, showing and that would sit all winter, and we would have a lot of soil runoff. So no-till or strip-till is reducing that soil disturbance. And then the other component to this is it's also leaving the residue on the landscape. So residue management kind of goes hand in hand with no-till, and it can manage the amount, orientation, or distribution of plant material. So that would be when you see now in the fall, which we're at, and you go drive around and you can see that they've taken the corn off, but there's still a lot of stalks and material on the ground. That's residue management, and we want that. So one of the reasons we want that is it helps build microbial activity in the soil because it gives them food, something to eat. It also, no-till, strip-till, things like that, increase infiltration because it allows root channels to form or wormholes to form, and you're not turning those up and cutting them off. So water can soak into the ground, which in turn then helps with plant available moisture. If the ground can soak up the water, the plant can use it. And then these practices also can help sequester carbon. So just kind of an example, the chart closer to me, not good with left and right. The one closer without do kind of shows you that when the raindrops will hit the ground and cause splash or soil disturbance to happen, and that soil then runs off into the ground, into our waterways. And if you look at the arrows pointing down, the infiltration isn't very high when you don't have residue. The other example over here, you get that splash, but the residue that's on the surface holds it in place and doesn't allow it to run off as easily. And it holds the water as well, so that the water can infiltrate into the ground. So residue management is a really important practice that doesn't get a lot of frills and spotlight and things like that, but it's an important practice, and I would say a lot of our farms are practicing this type of practice. And just to kind of show you, this picture is an example of what we're talking about with residue. Sometimes farmers might refer to it as trash or litter, mostly because it gets stuck in their equipment, but it's actually very beneficial for our soil and water quality. And then over here, I actually have a video showing what a no-till drill looks like when it's planting alfalfa into cover crops. So it's just a real quick little video. But you can see there's hardly any soil disturbance in that picture at all. So these little lines that you can see through here are where the crops are planted, but there's very little soil disturbance. Now this is going to be an example of, there we go, strip tillage. So this is where we're tilling some parts of the field or little strips through the field, but not the whole field. You may need to do this for a variety of different reasons, but it's an alternative to fully tilling the field. So if you look, you can see that there are lines where there's some tillage and some soil disturbance, but also lines where there isn't. So this is another practice that farmers are using on the landscape to help reduce soil erosion. So more practices. Contour farming. This is another kind of no-brainer one. You farm in your row patterns that follow the contour rather than going up and down the hill. This really reduces soil erosion. That little directional change of following the hills and the topography really reduces soil erosion. The other practice that goes in hand with this is what we call contour strips. And that's kind of this background picture where the fields are broken up with these grass sections, and then you have a field and then another grass section. And those grass sections allow you to slow down the runoff and trap sediment.
Should we try this now? Oh, there we go. We new batteries.
All right, maybe I don't have to keep this. Is that better?
Yeah.
Okay, good. Now I don't hear myself too, which is really weird. Contour strips also help increase water infiltration because they're slowing that water down across the slope as we go through. So this contour strips and contour farming, we see a lot in the driftless part of the county where we have more hills. But you will see it in parts of the northern watershed in the Mendota or off over by York or places where we have drumlins or other kind of topography that warrants these types of practices. So a big one that we work on, that my staff work on, we do over 5,000 acres each year working with farmers on cover crops. We do anywhere between 5,000 to 10,000 acres, just through our office, not including what the farmers do on their own. And cover crops are a crop that's planted as a temporary crop. So you're not really planting it to gain any money, you're not planting it to harvest or do any of that. You're just planting it to protect the soil from wind and water erosion. And it also allows a living root to stay in the soil, which helps keep the biology alive in the soil. A lot of benefits to cover crops, and there's a lot of variety to cover crops. So you can have a single species mix, and that's just one type of plant. A lot of farmers are using what we call cereal rye, a ryegrass, and they plant that because it grows really fast. Doesn't mind that it's a little cool outside, and it overwinters. It can survive through winter and grow back up in the spring. Some people will add other plants to their mix. They might add a legume because they want to add nitrogen to their soil. They might add turnips, for example, because they have a compaction issue, and the turnips will help loosen the soil. Or sunflowers might help also loosen the soil because they have deeper roots that help loosen and break up that compaction. So cover crops, depending on your goal and mission for what you want it to do for your soil, can have a lot of variety. And this is just trying to show you a little bit of some of that variety. One of the ways that we say there's variety is they how they're planted. So a cover crop typically has to go in the fall, and our falls are kind of short between harvest and when it maybe freezes. It's hard to say, it's unpredictable. So we have a lot of different methods to installing cover crops. We can use aerial seeding, which is using an airplane to fly the cover crop on. We can use a drone and use drones to do that. We also can wait until the cover crop is off the field and go in with that filter and plant it in there as well. And then some of these other pictures, this is just an example of a tuber root that was used in a cover crop mix. A multi-species mix might look a little different than a single species mix. So if you're driving along, it might look like a field, or it might have some sunflowers popping up in it, which is really pretty. The other thing is it can be a forage for grazing livestock. So especially in the spring, if you have a cover crop that survives through the winter, you can actually bring your livestock out and have them actually eat that cover crop in the spring before maybe other plants and things are going out for food. So it gives them forage opportunity as well. So with cover crops, there's a few different ways that you can plant. And planting green is kind of a new term that we're using. Not really a new practice, but new term. And it's where you're planting your main crop, corn, for example, directly into that living cover crop. So a lot of times in order to plant, you have to terminate or kill the winter cover crop so that you can go in and get your seed in the ground. Mostly because your equipment may not allow you to do that. or you need that material out of the way. This is a way, if you have the right equipment, that you can go through and plant right into that cover crop. So the really nice thing here, you're protecting that soil with a living cover, you're not disturbing the biology, and it's still adding organic matter to your soil. It also is really helpful with weed prevention as well, because you have a crop that's still there, and you're not taking it off and allowing weed seeds to kick in. So this is an example of what we call roller crimper planting green. So in the front of this tractor is a roller crimper that is rolling and crimping this ryegrass down so it gets out of the way, so that a piece of equipment behind it, the planter, can actually get down to the soil. But the nice thing is you can see it leaves this mat of vegetation that's protecting the soil. So if we get a rain event, the soil is not going anywhere because we have this protection on the surface. So you can kind of see the roller crimp in the front and that planter in the back. It does take some specialized equipment to do that, so not everybody does it, but we're seeing more farmers interested in that. Another one is interseeding, and this is where you plant your cover crop in between your row crops. So you plant your corn starts growing, it gets to be, you know, a couple inches tall, and you go in and you plant your cover crop in between. And the benefit here, again, we keep talking about it, is there's soil health components to it. You're improving the soil organic matter, you're increasing your biodiversity and the biology of the soil, you're helping reduce that soil erosion, which is protecting our water, and it also suppresses weeds. So I have another video here that kind of shows an example of that. Now, one of the things with this, it doesn't look a whole lot different to planting anything else really, other than you've got the rows of corn already growing here. Now different equipment can be set up different ways. This particular one, this is about 60-inch corn, which a lot of farms don't want to do 60-inch corn. They want to try to get 30-inch corn or something narrower because they want more crop. So you have to have the right kind of equipment to do this practice. But it is being done and trialed in the county. So what happens if you have manure? Because a lot of our farms do have manure, they have livestock, and they need somewhere to go with the manure. And manure is a great source of nutrients for growing crops, and is much better source than maybe buying commercial fertilizer that comes from who knows where. This is a local source with organic material in it. So one of the options that we have out there is what we call low disturbance manure injection. And this is where instead of going back through the plow and plowing that all under, you come in with this piece of equipment that injects the manure into the soil and leaves less disturbance if you're plowing it under. So it really has the opportunity to conserve the needs. It reduces some runoff. It also can reduce odor because that manure is going into the soil rather than sitting on top of the soil. It's preserving that residue. Also, we're still putting that residue on top of the soil. So this makes the most sense when you see it in action. But this is low disturbance manure injection into a cover crop. So took the crop off the field, they planted the cover crop, and now they're implementing low disturbance manure injection to inject manure into that field so it's ready for spring. But that cover crop is going to use and take up some of that nutrients and hold it through the winter until spring. So this is a really great practice that we are seeing with a lot of farms that have manure. Another practice that we're seeing kind of in the landscape is what we call rotational grazing. Sometimes it's also called managed grazing, sometimes it's prescribed grazing. They all kind of mean the same thing, but it's basically managing the harvest of your vegetation with livestock. This improves the soil because you can increase your species diversity. So animals don't like to eat just one thing, they like to eat multiple things, so you can plant your field with a forage mix of different species. It keeps the soil protected because there's a growing plant on it. And then it can also act as food or cover for wildlife. And just, this is a great picture because you can kind of see, when we say it's rotational grazing, means they have access to the whole field. They're only given access to parts of the field at a time. So here you see the grass is really low over here. It's kind of medium height here, but it's really tall down on the end over here. They're slowly moving the animals through this grazing pasture to basically mow down the grass here until you get to a height and that they're ready for moving to the next phase. So this is a really good practice for managing pastures, but also in areas where maybe water resources or things are a concern. You can plant it to a permanent vegetation but still of it. And then this is just an example of what it looks like if you're a bunch of cows switching pastures. So you can see up on the hillside, it's a lot shorter, and the cattle are moving into the area with tall grass. And they learn how to do this on their own pretty quickly because they're hungry and they know that when those open, and when that fence opens, the good stuff is on the other side and they're ready to go. So this is pretty easy to train them how to move through these systems. So now we'll move into a couple of the management or the structural practices. The two I really wanted to focus on was the first one is buffer or filter strips. And this is a strip of land that you don't farm, usually between your field, and then this would be a stream over here. And you keep this in permanent vegetation. You're not letting it grow up into weeds or things like that. You're keeping it into some type of permanent grass, usually vegetation. You don't want a bunch of buckthorn growing in there. You don't want all the various weed species in there. But what this does is when it rains and the water runs off the field towards the stream, it slows this water down and traps nutrients and it traps sediment in the buffer. So this grass will grow nice and tall. Because it's getting the nutrients, it's getting the water. And then later on, you can come in and even harvest that for hay. So if a farm has a need for hay, they can come in, mow this and collect it for hay. But we're also getting the water quality benefit because it's slowing down all of that water that would normally run off of a farm field. The other practice that's really common in crop fields that's more of a structural practice are grass waterways. And these are taking areas where we have concentrated flow. They're not necessarily a stream, they're not really anything, but the water likes to flow there. So the water's following the topography. And we can start it's seeded down the grass, and it allows that water to flow without gully erosions or carrying sediment with it. It helps protect these concentrated flow channels. It helps trap sediment and nutrients. It also filters and absorbs those nutrients, very similar to a filter strip. And they provide habitat within the field, depending on what they're planted with. So just some examples here. So when we say concentrated flow channel, it kind of looks like this, where it's just looks maybe like a stream, kind of a stream, but it's not there 99% of the time, just when it rains. This would be a concentrated flow channel. And if we get too much rain, they start to gully. And these are what some gullies look like around the county. So we don't want that because if it starts to gully, that's a lot of sediment that is leaving the site very quickly. So we design with an engineer grass waterway. We have to take into consideration how much water is flowing through, the watershed that's feeding into that area, and the velocities in order to slow down the water and allow it to follow this nice channelized area, which is all vegetated. So our goal is to keep it in vegetation and not erode and channelize like this. So grass waterways are an important practice in the landscape that you might see, like, why is there that channel running through that farm field? It's probably grass waterway. They're trying to protect and prevent the erosion. So there are impacts on implementation. There's a lot of things that go into, a lot of factors. One is timing. All of this takes timing. It's very tight timing windows. Planting, you want to plant your crops in the spring and you're trying to hit the perfect magic window of trying to plant your crop with rainfall and the sun and when the soil's warm enough. And then you have your harvesting your crops in the fall, but then you also want to install practices. When do you do all of that stuff? So the timing is an important component to planning when we're doing all of these conservation plans. We work with a farmer to try to figure out what that timing will be. When are you going to take your corn off the field? Should we do a cover crop? Sure. Do you want to aerial seed it? Because you want the seed there before you go take the crop off? Or are you going to come in after and do a no-till planter with that seed? So there's a lot of factors that go into this. If you're using manure versus commercial fertilizers, there's factors that get related to that. So if you're using manure, you might be looking at that low disturbance manure injection. Commercial fertilizers, they might be more passes across the field causing compaction. So you want to look at some of those factors to determine which management practices you want to select. One of the things that we're doing a lot of research on right now is cover crop termination timing and methods. With our Dane demo farms, we are looking at time to kill off a cover crop and get the field ready to plant. Because we can't, not everybody's planting group, and so it doesn't work for everybody's equipment. But we want to get the maximum benefit of that cover crop and the vegetation on the landscape. So what is that timing? What are the different methods? I should be a crimper, that's one method. You know, other folks will go in and maybe they'll have to spray their fields. But if they're gonna spray the field, are they gonna spray it 2 weeks before and let it sit? Or are they gonna wait until after they plant it? There's a lot of timing components associated with that. Access to equipment is a big one. If you don't have a no-till drill, it's really hard to do no-till. The county does offer programs to help farmers purchase equipment to implement some of these practices. So we do have a way to assist them to get the right pieces of equipment. But if you don't have access to it, that's hard. Or if the operator, that can be a challenge. And then always weather plays in all of this. We typically find gullies in the spring or in the fall. Not because that's when the rain is, but that's when the crops are off the fields. So when you see a big corn field in the summer, it's really hard to see that gully out in the middle of the field. But when they plow it and they have to drive through it, that's when we get a lot of calls in our office, is that they've discovered a gully and now they want to fix it. But weather plays into that too, because we have to fix it in a time frame when we can get the plants to establish, and we do have winter. Winter doesn't always help us. So those are factors that all go into the planning and selection practices. So I think with that, I'm done, but I would like to know if you are driving out and about in the countryside, we've done these signs that say cover crops and work for health and water quality. So if we have farmers that are participating in programs and they let's put a sign out, you might see these signs out and around the countryside, showing you that there are practices going in and that farmers are doing good work.
Amy, thank you. We're gonna go ahead and do a little Q&A. If you have questions, please go ahead and I'll pop the mic over. Remember, this is the mic you gotta keep close.
A question about the cover crops, the grasses that are growing, that you might need to plant your crop on. Is there something special or different about there you can update that they can be living alongside the crop? What you call weeds, you want to get.
Yeah, that's a good question. I think the really bring pests and other things to the crops. Where the cover crops, because we're planting a very specific species, or they have different root depths. So one of the things is we're looking at not only the mass above the soil, but we're looking at the root depths that they go below. Weeds don't typically have very deep roots or anything like that, so they're not really helping us. Where these cover crops, we can design a mix to meet all of those goals with plants that meet those different goals. So yes, will they take up some of the nutrients that could be going to the corn or the soybean or whatever? Yes, but they could also be providing a bunch of other benefits that help us use less pesticides or less herbicides on the field.
Great question. Keep it close.
Yeah, previous presentations where they've documented that the vast majority of the phosphorus runoff from the first fields does occur in a 20 to 30-day period in like late February, early March. We have an early spring rainfall over frozen grounds, and I think it's the manure runoff that really runs off and causes the vast majority of the crop. Is the only practice you've gone over that would curtail that with underground injection? And is there any way that we could, I think that's manure management. Is there any way we could address that 20 to 30-day period where we see the majority of the phosphorus runoff?
If you never read all of that.
Yeah, no, sorry, just the question. Thank you.
The question was about phosphorus runoff during the February-March period and what practices basically could we do during that time frame other than low disturbance manure injection. So low disturbance manure injection is one thing, getting the manure into the soil rather than on top of the soil. But cover crops can also help with that, because even if you have a cover crop that doesn't overwinter, for example, barley doesn't overwinter, it'll die. The vegetative mass is still on the surface and can help hold that water and have some holding capacity that way. So cover crops are really, keeping a vegetated cover is an important practice to that. And so we are seeing a lot more farmers implement cover crops, and especially cover crops that overwinter.
A reminder, the volume here, it's not just so we can hear each other, but so that the folks watching later can actually hear on the live stream too.
Thanks. Given that Columbia County lies upstream in the O'Hare watershed, you get cooperation. Do they have a similar position as yours and running similar programs?
Yeah, Columbia County offers similar programs. We work with them quite a bit. We have a joint project right now that we're doing in Spring Creek watershed, which is kind of up by Dane and Roxbury, that goes into the Columbia County side of the watershed to Okie Bay. So we do collaborate quite a bit with their county, and they offer similar programs based on what their county board and things approve.
Thank you.
I just had a follow-up question. You were alluding to the idea that cover crops can help prevent pests and therefore prevent need for certain chemical pesticides or things like that. I think I heard you saying that. And I was just wondering, because I honestly don't understand why do cover crops actually help prevent pests, if that's what I understood, if that's correct.
Yeah, so cover crops, they're keeping a few different things. They're keeping a living plant on the ground. And a lot of times when we're talking about pest management, it might be more of a cover crop that is a multi-species cover crop that they would be looking at, because then you're getting some diversity and bringing in other insects that are predator insects to those pests. So when you start doing that, it's starting to build the biology of the soil and that whole makeup. Where if we're not, plowing the field under every year and disturbing that biology, we're able to use less pest.
Hello, thank you very much. Great presentation, appreciate it. So we know phosphorus is one of the problems we have that's in our river and lakes, and we're getting more good data about how much is in there, and we know it's hard to mitigate it and expensive. So there's a lot of incentive, obviously, to stop more phosphorus from getting there. Are we starting to tie the data set together from what's coming off the fields with what's been coming in for many years so that we can say, like, what you showed is there's a lot less tillage happening now, and we have new techniques and so on. But it's usually that last percentage, the last, 10%, 20%, 30%, that really gets you to your goals. And so do we have the data so we can get to those last percentages to stop the phosphorus from getting into the rivers and lakes? Or is there still a huge amount of work we need to do to incentivize the ag community to do that?
Yeah, I think it's a combination of both. I went back in the slides to this slide here, because we didn't get, I didn't talk in depth about this at all, because it gets us really into the weeds. But on this chart, you have soil test phosphorus and what we call the phosphorus index. Soil test phosphorus is when the farmers go out and actually test their soil for phosphorus, nitrogen, and potassium to determine how much they need to grow their crop. And if there's enough in the soil, they don't need to add additional nutrients. And so typically what we like to see are definitely numbers under 100 in the soil, and usually less than 50. So our averages are not too bad when you look at the our watershed as a whole. Now that's not to say individual fields higher because they're averages, but on average, we are seeing those numbers decrease with time. Then the phosphorus index, the state law requires you to have a phosphorus, which is a calculation based on your soil test, how far away you are from a water body, your soil types, and a number of other things that go into that calculation. That phosphorus index for the state is a 6. That's what's allowed by the state. Now, most of our farms in Dane County are operating much, much lower than 6. So they're in the 2s, there's a couple 3s, 1s, things like that. So this phosphorus index is another method that we use to kind of see, are we going in the right direction? And so if you're allowed to be at a 6, but you're down here at a 1, there's a gap there that says you've made improvements in the amount of phosphorus that are running off. So that's like the potential for runoff. So we are tracking both of those numbers to try to see what the trends are. And the trends so far have continued to go down, but soil test phosphorus doesn't change overnight. It takes time, so we are still monitoring some of that stuff.
Is the county making any effort to get away from just the rotation of corn, beans, beans? Like, for example, to do more perennial crops like Kernza and things like that. It just seems like we're never gonna get reductions in erosion and phosphorus and sediment if we just keep going corn, beans.
Well, part of it is what the farm needs. So that's part of it, but we do have a number of farms that are starting to explore adding things like Kernza. That we've had trials with switchgrass. Adding more winter wheat into the mix is another one. adding more alfalfa into the mix is another one. So we do have a lot of farms that are starting to increase that when they have a use and a need for that plant, or if there's a market for it. But, we do have dairy livestock, and the dairy, livestock operations do rely heavily on corn and soybean. But there are other examples around the state where they're incorporating other plants in dairy heavy parts of the state. So I'd like to see those trends continue here too.
Having grown up in a farm in Oklahoma, along from here, the size of the farm makes a huge difference. Equipment's expensive even with programs. So what's the average farm's acreage that people are more receptive to these ideas that they should?
I don't know if we have a targeted size. I mean, the average dairy farm in Dane County is about 250 acres. 200 to 300, so. But we're seeing farms with 40 acres do no-till, and we're seeing farms with 5,000 acres do no-till. So, I think our program that we have for the equipment actually has incentivized quite a few people to make transitions. Has it encouraged everybody? No, not everybody. But I don't know if it's so much farm size as it is farm management, what their goals and mission are with their landscape.
Moving down slope a little bit, I'm curious about some of your in-stream management activities. Specifically, the stream ag work that Dane County's been very strong in. But more specifically, I would like to hear what kind of results you've gotten from your Suck the Muck campaign. Frankly, it's been very difficult to hear any concrete results, good or bad. So I'm wondering if you could just give a little rundown on how that's working out.
Sounds like another skill. I don't work specifically with the Suck the Muck program. That's a program within our department, but I don't personally with that program. But it's still progressing with time. Door Creek is the one that it has been being worked on currently, but it sounds like that's a good suggestion for a future talk, is an update on the Suck the Muck program.
I'll just chime in on behalf of the county. One of the things that Dick Lathrop talked about with the Clean Lakes Alliance and the county is one of the reasons to Suck the Muck is for a blowout event, right? So if you get a large rain event, highly concentrated in a creek that's going to a lake, and you get many inches, that sediment would actually blow out into the lake. So while you're getting residual help all the time because the flow keeps going and constantly dripping phosphorus leaching from the sediment, you're also preventing a possibly really bad turnout if you have a large rain event. And all that one. We'd be happy to bring the county back and actually show you numbers. It's a great program. It was identified way back in 2012, and the county really took it to the next level. But it is working, but it's also preventing a future episode of some sort.
Thanks, Jan. Any more questions, guys? We still have a good 5 minutes or so.
Thanks. I still see drainage tiles coming into the water bodies. Is there any move to get farmers to eliminate those drainage tiles, or at least break them back from the actually going right into the creek and going into buffer strips instead?
That is a kind of emerging practice that's coming to Wisconsin more. I think it's been used quite a bit more in Iowa State. But we do have some areas of the state that are doing some pilot testing practices to see if they work. So some, they call them phosphorus reduction systems, where it's kind of like a tank that the tile line goes into, the removes the phosphorus before it discharges. So there are some experiments going. Discovery Farms is working on some of that. And I think you'll see more of that coming in the future.
Amy, a question about the reception from farmers. Specifically, I'm just kind of interested in the, are you guys presenting this as an option in these plans for legacy farms around the area in Dane County, or is a lot of new farmers, perhaps new generations coming in? What's the demographic of the farmers that you're working with?
Oh boy. It ranges. I would say we have new farmers coming in. We have sons or daughters that are taking over the farm, you know, and they've just, you know, went through college and they're coming back to the farm, and they have a lot of new ideas and things that they want to try and push farm to the next generation and level. And then we have a lot of folks who have been farming for 50+ years who are also saying, maybe I do something different or leave the land a little bit different for my generations. So we work with everybody. They want to come in the door and do conservation, we'll work with them.
Any other questions, group? One more, yes, all right.
Just to spin off of that good question. What are you noticing that farms in general in the county, are they growing? Are they shrinking? Are they, like, what's the status of farmland in the county and how is it evolving?
There's a few different factors that go into that. One, we have a lot of development in Dane County, and the development's happening somewhere, and a lot of times that's cropland that's being bought up and converted into development. So we have a general trend of where we're losing agricultural land in the county. But then farms, it really varies. We have farms of all sizes, you know, 20 acres up to, like I said, 5,000, 20,000 acres. They may not own all the land. That's probably the one thing that's changing, is the land is much more divided up and owned by lots of people. So they may be renting more land than they did in the past. But farm sizes, they kind of vary depending on the needs or what they're doing with that.
That's a perfect question to tell you about something that the Clean Lakes Alliance is working with the county on. As you know, we do the State of Lakes report every year, which has a water quality assessment for our lakes in it. We are partnering with over 22 organizations, including led by Laura and her team and the county executive, to add a land health assessment to the State of Lakes report, i.e. a farmer is renting land and how much is going to be put in housing in the future, versus how much is being agriculture, how many green roofs in our community, rain gardens, cover crops. And so we're partnering to come up with some great metrics to show the progress that actually has been done over the last 10, 15, 20 years, but also where we need to go in the future. So look forward to that, and your support is always welcome.
Awesome. Thank you, James. Amy, thank you so much for joining us today, guys. It was a really wonderful, engaging conversation. I'm gonna cheat because I left my notes up there. Caitlin's the best. As usual, if we didn't get to your question, or if you have something else that pops into your brain on the drive home while you're stuck in traffic, you can always email Clean Lakes Alliance. It's info@cleanlakesalliance.org. They will either connect you with Amy to get an answer, or one of the other myriad of people within the Clean Lakes Alliance network. Somebody will have the answer for you. The entire presentation will also be available on the Clean Lakes Alliance YouTube channel by tomorrow morning. you've been here before, you know my usual spiel here. It's really nice to share these videos. Usually I send them to my parents. They're kind of new to the whole conservation conversation, so it's nice to share that knowledge around. We are gonna be back here in November, on the 18th for our next 101. We're going to hear from Ho-Chunk Elder Janice Rice, who's gonna share some really neat values, teaching kinship and relationships that frame Ho-Chunk worldwide, or their worldview. It's gonna be a really good conversation. Again, a nice engaging conversation, I think, afterwards as well. We have more information about all of our upcoming events that can be found on the Clean Lakes Alliance website. Thank you again so much for joining us this evening, guys. Have a safe drive home, and we'll see you in November.
Microphone.